Hello, welcome to Brown Dog Gadgets Live. I'm Amanda, the Education Outreach Coordinator here at Brown Dog Gadgets. Behind the camera, I've got Pete.
Hi.
It's been a nice long stream of Pete with me. It's been great.
I'm out tomorrow, but we don't stream tomorrow.
It's all right.
Are you here tomorrow?
I'm going to work from home tomorrow.
There you go.
Yeah. I like doing that when, I don't have a live stream.
Friday's a good day for that.
It works well.
All right.
Yeah. Today we are jumping into chapter 23 of MicroBit University. And there's so many more to go.
Yeah.
But before we do that, if you have not followed us on our social media platforms, please do so. You can find us on Facebook, Instagram, Twitter, or X, and YouTube. Also, the guide for the project you'll see today, as well as all of our other projects, products, and templates can be found at browndoggadgets.com. And then if you have any questions or comments, feel free to chat with us as we stream. But if you have questions after, you can always email us at help@browndoggadgets.com.
Yeah.
All right, so we've been jumping into the NeoPixel Stick.
Yeah.
And it just is so colorful sometimes. And it is definitely one of my favorites. So we've got the NeoPixel Stick with the Potentiometer today. Let's switch to the overhead cam.
There we go.
All right. We're blurry.
Let me focus that.
Yeah.
Yeah, it's funny. This thing reverts to autofocus, and then it's out of focus. So you
It's
have
so
to
weird.
manually focus it.
There we go. That's better.
That's slightly...
So we've got
There we go.
our NeoPixel Stick that is then attached to our connector. I'll just pick this up for a second. This is a 3D printed holder, so if you want this file, you can print your own. It's up on our website under the 3D printable files.
It is.
And then it's just a Lego
Beam.
Technic beam
Got it.
and some Lego bricks.
Yeah, you can use a
Just
1x1
stick it down.
or a 2x2 or whatever.
Yeah.
Yeah,
You
easy.
don't have to print this out. You could also, rubber band it down to couple pieces of Lego. There's a lot of options. You just want to make sure, and I know Pete mentions this in the guide, you want to make sure that the connections are off to the left.
Mm-hmm.
So the actual numbering of the NeoPixels actually makes sense when you're coding it.
Yeah.
Did I get that right?
Yes, I had someone, they were using the 7-segment display, and they're like, it's just gibberish. Why isn't it showing? I rotated it up, and you're like, oh, yeah, it's upside down. Yeah, it happens.
It can be a little confusing sometimes.
Can be.
Yeah. At least with the 7-segment display, it has words at the bottom.
It does. You're right. It does.
Technically.
Yeah, it does. You're right.
But if you don't pay attention to that,
Yeah, it's fine.
I can guarantee I haven't in the past.
Nah.
All right, so we've got our NeoPixel Stick that is connected with our ribbon cables to, I believe, pin 13.
Yeah, we're still using pin 13.
Yeah.
Why not?
Nice and easy because it's the first one in the bunch back here.
Yes.
And then we have our potentiometer connected to ground, as well as pin 0, and then our 3-volt connection. So we've done those all before, but now we're putting them together.
Yeah.
So the very first one is called NeoPixel Potentiometer, or NeoPixel Stick Potentiometer Bright. So
There you
when
go.
I turn up the potentiometer, it gets brighter. Unless Pete turns the color down in
I'm trying to
the
make it better.
And then when I turn it down, it gets dimmer.
So this, yeah, turn it again. So this, yeah, that full brightness, that's why, like
Woo!
we say, we often don't use it at full brightness because it's pretty good. In person, too, it's like,
Yeah, I am definitely only looking at the screen right now because if I look directly at this, I might blind myself. Well, not at this level.
Yeah, it's pretty good.
At
though.
this.
I'm gonna
It's
use
blinding.
I'm gonna use a couple of these to make some bike lights for when it gets dark out.
I love that idea. Awesome. All right, let's check out the code, Pete.
Okay, let's jump over.
We're going to turn this down a little before I blind myself accidentally.
Right. Okay, the code. Let's get to that code.
I love the colors on these. It just makes me happy.
Right. Okay.
So fun.
So, code on this one is super simple. I know before we always set the brightness in the start just so that we have something to work with. So for this, we're using. Did we use Show Rainbow?
I don't think so.
Okay.
Unless you did with the push button
Oh, we might
and the
have.
NeoPixel
I
Stick.
don't remember.
But Josh did that with you.
It's new code every week. I
So.
forget. But yeah, show rainbow is one of the options in here. I'm sure I missed it already. Show
there
rainbow.
It is.
Show rainbow. So
Yeah.
and it has this 1 to 360.
Mm-hmm.
So you'll see it's kind of like starting with red and ending with red.
Oh, yeah.
Yeah. I mean, they're probably close enough reds, or I don't know if it's 360 is all the way around the color wheel and back to the beginning, but we'll get to that in another guide. But basically what we're doing here again is we're doing that show rainbow. We're doing 1 to 360 to get that, and it'll scale that rainbow to however many pixels you have. So if you have a big long strip, it'll have like that gradation of colors across it. Let's see what Mike, I know we talked about Mike, were you here with Josh last week where he went into great detail about using multi-pin LEDs versus NeoPixels? And yeah, we're huge fans, obviously. They work great for the stuff we're doing. So yeah, after we do our rainbow, then we're going to use we're going to set a variable called rotval, which I use as rotational value, I guess, from our potentiometer. So we're reading it on analog pin 0. And I think you already showed we connect it to ground and to 3 volts.
Right.
So basically you're running that 3 volts and ground together, and then you're kind of like siphoning off. The pin 0 reads that voltage, but you're changing the resistance when you turn that dial.
Okay.
So it's reading some value between 0 and 3 volts, and that's how we get our 0 to 1023 or whatever, and it's whatever value it is. So hopefully that makes sense. And we do round. Yeah, we round it just because otherwise you're going to get decimals. 300 or 300.257, whatever. So we just round it to get whole numbers. Sometimes that matters, sometimes it doesn't. I just like to
I'm guessing with show rainbow it probably, or with brightness it doesn't, but
it might. We'd have to look at brightness. It may expect whole numbers. We don't
that's
know.
fair.
Because I feel like at one point I was writing some code and I didn't have round, and it kept not working, or not working how I expect, and I'm like, what is going on?
Wait, can you hover over the block that says set brightness?
That one?
Because there were some words that popped up at one point. Oh yeah, see, something showed there.
Okay, hold
I'm
on.
wondering if it would say, all right, well.
Set the brightness of the strip. The flag only applies to future operations. Right. So because we're setting it here, it
Right,
won't
anything after
have
it.
effect until it loops around again, basically. But yeah, so it's continually showing the rainbow, reading the potentiometer, and then setting the brightness based on it. So, as you turn it, it's going to keep changing.
I love this one.
Right.
So pretty. All right, I guess I'll move on.
At some
Alright.
point, see, the nice thing is at some point,
Oh,
what you do? Yeah, it's going to stay like that.
just took out the MicroBit.
At some point, if we add the 7-segment display NeoPixels and a potentiometer, you could see what value is the correct brightness on the little 7-segment display.
So why
Just
does this stay lit?
So the MicroBit has sent the data to the strip, and we call it a smart LED. It basically has like a tiny little controller in it that captures that data we sent, and it holds it. So it's still getting power, and it's getting the last command we sent to it,
Got it.
right? So we told it to do a thing, and it still has power, and it's still doing that thing.
Yeah.
Even though it's not, until we do that show again,
Right.
Give it a new command, it's just going to keep showing that.
Cool.
Because it's still got power.
Right.
Yeah. We're on to the
All right.
next one.
So our next one is Larson scanner.
The classic Larson speed on this
Yeah.
one.
So this
We're gonna call
one is the Larson scanner going back and forth.
it. Is.
But as you turn up the dial, it speeds it up.
You got it. Go all the way. See how it looks on camera. Oh, yeah, we're losing them.
Yep.
Which is...
It looks really cool in person.
Frame rates are fun. I had a lot of fun filming these, too, because... all right, back at
We'll
the
leave
code.
it about there.
Right. So, same kind of thing here, and we're just... we're reading the potentiometer here, pretty much the same. I think the difference here is we're doing a reverse map on this one, so we're mapping the 0, 1023 to 150 to 0. So we've reversed the order of it, which is fine. You can do that with a map. And then we've got this function called move pixels. So when we look at that, and I feel like we did this maybe a week. Maybe you weren't here last. Were you not here last week?
I was not here last week.
Okay,
you had Josh.
Some of this might look familiar. So what we're going to do to begin with is set our, we're basically going to create two routines that have the pixel go from left to right and then right to left. So we're going to set it at 0. We're going to repeat this 7 times, and each time it's going to shift over 1 pixel.
Yeah.
And it's also going to pause between each shift. And that pause is the number that gets called into our function here. So we get this value from the potentiometer, anywhere from 150 to 0, and then we pass that parameter into our function. So it shoots it over there.
Right.
If you say, Josh, go get me lunch, and he's like, oh, what's a guy? You say, Josh, get me a hamburger. I mean, the hamburger is the parameter in that statement, right? So we do this part, and once that's done, it ends with that pixel over on 7. And then we just tell it to do this. Well, start at 7 and then repeat. And then we do our shift in negative numbers here.
Yeah.
So it goes back to the left.
And I believe this looks very familiar to the first set of NeoPixel Stick guides.
Yeah.
You did a lot of the shifting back and forth in those.
Without any control in it or something.
Right.
So we figured there's a nice way to kind of add control for the speed. Potentiometer is a great component for that.
Yeah.
Okay, Mike, of course, a big fan of the Larson scanner, I'm sure. Just throwing out random Knight Rider dialogue.
I support it.
Anyone over the age of, you know about Knight Rider?
No. So 42.
Anyone over the age of 50, guy.
I mean, know of, yes.
Okay. You know about David Hasselhoff, right?
Yes. From Baywatch.
Baywatch, right. You must be younger than me.
Is that not the answer?
That's fine. They should have given him a cool robot car in that show, too. But
yeah.
All right.
Awesome.
That one makes sense.
So that is guide B. Yes.
It is.
Larson, scanner.
Yeah.
I think you said something else.
Larson speed, I think.
Larson speed. Yeah. There we go. I just wrote Larson on
my
all
cool.
Post-it note over here. And guide C is rotate steps.
Okay. What did I do here? Let's move this over here. Easier to see.
All right. So when I am all the way down to the left, it does absolutely nothing. And Pete will talk about that in a minute.
Still doing something.
That's fair. And then if I turn it just so slightly, it's going to step 1 to the right and then loop back around. And if I turn it more, it's stepping 2-ish. Yeah. And then, no, not there yet. There we go. Now it's stepping 3.
You got it.
Awesome.
That's our limit. Cool. So, again, the start all looks pretty darn similar. We used green this time.
Why not?
Why not? And what we're going to do over here is, once again, reading our potentiometer. This time, we've mapped that full scale between just 0 and 3. So it's basically 4 positions. And you saw when you had it all the way to the left, it looked like it wasn't moving because it wasn't. It was rotating that pixel 0
by 0, right?
Each time around, it's like move 0. Well, 0 is the same place.
So, and if I took it all the way down right now, it's back to 0, and it's on a different pixel.
You got it. Yeah. So as it's moving, because we just set the position here in the start, and then we're just using that rotate, which, if you remember, just kind of goes round and round and round. and with a little pause between each step. But yeah, so this basically turns our potentiometer into just like a 4-position switch, as it were. So it's yeah, that's an easy way to do it. You could do this with a push button as well, like every time you pressed it or click, 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 it would cycle through a certain number. But, you know, potentiometer is a good option as well.
Yeah, absolutely. Nice. All right.
Great.
That is guide C. And then the last one we have for this guide today is Rainbow Steps.
Rainbow Steps.
It's my fave.
Good, good, good. That's a good one.
It's colorful time.
Yeah, right.
It's so pretty.
Okay. So I think the only real difference with this one is instead of lighting up a single pixel, we're showing the rainbow. Now, you'll notice this time we didn't go to 360, we're going to 315. Mm-hmm. So I did the funky math and figured out, like, well, 360 divided by 8 is, I don't know what it is.
A number.
I subtracted that from 360, and then we get the rainbow without
the extra red on the end.
Red in there
Got
twice, as it were. Yeah, and then all we're doing is the same thing here. We're just rotating it one. Mm-hmm. But because it's not one single pixel, it's the whole rainbow. The whole thing seems to move.
Yeah.
And I think we talked about this, but as you start from the left and turn right, mm-hmm. When you get about past halfway, it looks like it's moving backwards, basically to the left. Optical illusion.
There we go.
So like, yeah. So like in film, it's because it's not stepping. You know, it's stepping a few less. And in the film world, it's called like the wagon wheel effect. If you've ever seen old film where like a wagon wheel or a propeller or anything that's circular mm-hmm. looks like it's going backwards or even not moving. It has to do with the frame rate and how it's captured in relation to the object. So.
And when it's on 8, it looks like it's not moving at all.
But it is.
Because it's rotating by 8.
Exactly 8. So
they're staying in the same spot.
When I was reading on the effect, I guess there's some weird issue where like certain lighting can be like kind of strobish, and I guess in machine shops it can be dangerous because like if a lathe is spinning at a certain rotation and the lights are flickering to match that, it may look like it's not moving. Oh. It can be like an extreme dangerous situation. It
sounds like
thousands of times per second and it looks like it's not moving or something.
Yeah.
So it's kind of a funky effect, and you can kind of see that happen when you turn that dial and mm-hmm. see like it's moving backwards, or like it's not moving, but it is moving just exactly. And that's the whole like, oh, that wagon wheel isn't moving, but the whole wagon's moving because it's matching up. Yep. Anyway, I've talked way too much about that.
But it's so cool.
Yeah. And the other thing I want to mention, so with the potentiometer, take it and just remove it from the board.
You got it on there tight.
It's on there tight for a reason. Okay, so it's still moving because we have something called a floating value. So as I talked about, that pin 0, it's reading an analog value, and it's looking for some voltage between 0 and 3 volts as it flows through the potentiometer, mm-hmm. and you adjust the resistance. If you don't have any input on that pin, it's what we call a floating pin. So it'll have some just random value between 0 and 3 volts, or basically between 0 and 1023 mm-hmm. when we read that value. But it's usually about middle, and it kind of jumps around.
Yeah.
So it might be.
It looks pretty middle right now based on what it's doing.
Yeah. If we put like the previous one on the previous code, it would probably just be moving slowly because it would be about halfway-ish. So. Yeah. But it'll jump around. It won't be exactly half. It'll be like 400 something, 500, 600. It'll jump all over the place. So mm-hmm. if you ever get weird, funky things happening with a potentiometer, make sure it's properly connected. So and that's why if you turn it all the way to the left, it should stop moving, right? Yep. And now like lift it off a little. So like if you don't have a good connection and it shouldn't be moving, and it's doing that, well, check your connections.
It's a solid connection. I barely
Solid
touched
connection.
it, Pete. Look at that.
Which, I know. At some point,
You worked hard on that one.
We should get into, remind Josh, we should do some debugging and show, like, how to use the serial monitor on the computer to see what those values are. Although we could do it with the
Sure.
7 segment as well. Those are more advanced things.
Yeah,
But
I believe you.
that's what we got.
Awesome. My favorite so far.
It's a good one.
Yep. All right, that is all we've got for you today. Next week, we've got some projects. I don't actually remember what we're doing. Actually, I think we're doing the Witch Wand.
Let me see.
I think Tuesday is the Witch Wand. And then Halloween hats is Wednesday.
You are correct.
Yes. And then we've got
That's
our
all I have scheduled so far.
next MicroBit University, which will be chapter 24.
Yeah.
Which will be something.
I think we're doing the 270 servo, maybe?
That sounds
We
right.
might be jumping into servos at this point.
I think that's what we decided, and that's what I put in the newsletter. So
Yeah.
I think that's what's
We
happening.
better do it.
Yeah.
Yeah, I mean, Josh can tell us if we're wrong, but I'm pretty sure that was next up.
We'll just tell him we're right.
We could just do it, too.
It's fine. He won't notice. He doesn't pay attention.
He does. Sometimes does. When you least expect it.
It's true.
He's-
And then really cares when you least expect it.
Exactly. Where are we going, Michael? I don't even know.
Probably home soon.
We're going home.
Yeah. But
Okay. Yeah.
if you have
before
not
that-
followed us on our social media platforms,
Do
you
that.
could go to Facebook, Instagram, Twitter, or X, or YouTube and follow us.
It's true.
Yeah. The guide for this project, as well as all of our other projects, products, and templates, can be found at browndoggadgets.com.
Sure.
And then if you have questions after, you can email us at help@browndoggadgets.com.
Ooh, and I started working through some of our new 3D files to get online. So
Like this one?
that one's next. I just did the paw tray. So
Yes.
that one is on printables now. It's in our GitHub repository. And then I still have to add a guide for it on our site. But I think the crank handle.
Oh, yeah.
And some other
That we haven't really done anything with yet?
Yeah, the beam holder is on there. But yeah, I'll do that multi-microbit holder probably next.
Cool.
And trying to think what else. Oh, and that new motor mount, I gotta take photos. But yeah,
Yeah.
we're getting there. We're gonna get all that stuff on there so people can. Oh, and a few people did print our pin players, and one person printed our little microbit holder thing.
Yeah.
But they changed it. They took off the battery thing because they wanted to fit them all in some box they had, and they're like, I just use Velcro dots to stick the battery thing on. So I'm like, cool.
That's a great idea.
So it's good to see people using these things
Yeah.
and appreciating it, and we're like, hey, yeah, remix it, do what you want with it. Just obviously don't sell it, and maybe give us credit. That's all.
And
We just
then-
want to make these available.
There's another one. I thought of
There's
it,
another one.
and then it left my brain.
Another what?
3. Oh, are you going to put up the large and giant microbits?
Yeah, Josh was hemming and hawing on that one.
I
think.
noticed, yeah.
Just because doing a build guide for it it's like super advanced with the way the multiple NeoPixel grids are in there or whatever, and they're soldered together, and then there's a controller and there's a lot of code. So I think he was like, I don't know if it's going to be way too complex and take too much time. I don't know. We could also just do the print files maybe.
Right.
So we'll ask him. He's in charge right here.
So maybe, if you want it.
But yeah,
Let
he
us
did
know.
say, he's like, even if people just print it out and it's non-functional, it's still
Yeah.
pretty cool. So
Absolutely.
let me just say, Mike, send us a self-addressed stamped envelope, and we'll put it on a.
Did he mean send it or send the file?
We'll put a magnetic tape in the mail for you. You can compile it from source and have your own version.
Look at that. So fancy.
Right.
Awesome.
I think we're done.
Hopefully we'll see you next week.
All right.
Have a good one.
Yep.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media @browndoggadgets. We'll see you next time.